Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And remember, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Anyways, the puzzle today is called the Meretricious Puzzle by Half-Baked Lunatic, apologies, aka David, I believe it's Workman, but I'm not sure actually because it doesn't say the whole thing. Um, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits along a green line must differ by at least 5, the German whisper rule. And this is a German whisper line, and this is a German whisper line. So if this were a 3, this would have to be an 8 or a 9 to be adjacent to the 3 because adjacent digits must have a difference of at least 5. Purple lines must contain a contiguous set of digits in any order. Renban rule. So for example, if this were a 1, this would have to be 2 and 3 to be with it because otherwise there would 1 is only in a contiguous set with 3 digits of only 1, 2, and 3, right? 1, 2, and 4 is not contiguous, and neither is any other 1 set. It's only 1, 2, and 3 that are contiguous. So that's the Renban rules. Digits along red lines must read the same forwards or backwards. So as an example, this could be like 1, 4, 1, 4, 1, because it reads the same one way, 1, 4, 1, 4, 1, as the other way, 1, 4, 1, 4, 1. And that's how that works for palindrome rules. And then digits in cells separated by a black dot must be in a 2-to-1 ratio. Black dot crop key rules. And all dots are shown. So therefore, we have a negative constraint here, which means that if, say, this were a 2, this would have to be a 1 or 4 to maintain the 1-to-2 ratio. And in addition, all such dots are given. So that means there cannot be another pair of cells which have a 1-to-2 ratio unless specifically they have a black dot in between them. So there's no, in all the other cell relationships, there is no 1-to-2 relationship. And that's what we usually call as a negative constraint, because all dots are specifically shown. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first. What we couldn't have previously that I give an example of is this actually being 1. If this is 1, this would have to be a 2, but then the 1 could not be in a 1, 2, 3 contiguous set of digits on this Renban line. Therefore, this can never be 1. So it can never be 1, 2, and 4. But this way could be 1, 2, or 4. So this could be 1, 2, or 4, or it's 2, 4, or 8. Or this is 2, 4, or 8. But it can never be 1, 2, 4 this way. We know 3 of them are in. So anytime you have 3 cells separated by 2 black Kropke dots, you know it's either 1, 2, 4 or 2, 4, 8. Well, that eliminates all other doubles in that box except for 3 and 6. So this must be 3 and 6. So if this is, and we know 4 can never be on this line except as the last one. So if this were 2, this would have to be 4, and this could never, I guess it could be 2, 4, 8, and this could be 2, 1, and 3. If this is 4, 2, 1, it could be 4, 3, and 5, or 4, 6, and 5. If this is 8, this is 4, this is 2, which means this is 8, this would have to be 7 then, and this would be 3, or this would be 6 in that case. We know this pair cannot be 3 and 6, so it's either 1, 2, 4, or 8. This cannot be 3 or 6, so this is also 1, 2, 4, or 8, which means this has to be 1, 2, 4, or 8, which means, of course, this is 1, 2, 4, 8, which means it must be with a 1, 2, 4, 8. And as we said, if we have 3 cells separated by 2 black Kropke dots, it has to be like in a row or in a box together or in a column together. We know specifically that this has to be 1, 2, 4, and 8, 1, 2, 4, or 2, 4, and 8. So this is 1, 2, 4, and 8, and this is 2 or 4. This cannot be 2 and 4 specifically. We also know this has to be 1, 2, 4, and 8 also, right? So this is either 1, 2, and 4, or the other way, or it's 2, 4, and 8, or the other way. Therefore, we have a 2, 4, 2, 4 pair in row 2, which eliminates 2 and 4 from the rest of the row. Therefore, this must be 1 and 8, and this must be 1 or 8. So 1 or 8 has to be with a 2 or 4, right? 1 and 8 is not in a 2 to 1 relationship with any other digits besides 2 and 4. Cannot be with 1 and 8. It has to be with one of 2 or 4. We know this can't be 1, 8, or 2 or 4 because of the 1, 8 pair and the 2, 4 pairs. Therefore, this must specifically be 3 and 6, which means this is 3 and 6 also. So since this is 3 and 6 and this is 3 and 6, so we have a 3, 6, 3, 6 pair here and then 3, 6, 3, 6 pair here. One out of the 3 or 6 must be in the area surrounding the black Kropke dot here. So therefore the other one must be 2 because 3 and 6 is only in a 2 to 1 relationship with the other 3 or 6. So this is 3 or 6 also. This cannot be 3 and 6 because that would eliminate both possibilities here. So this is 1, 2, 4, 8. This one could actually be 3 or 6, so we're not actually sure. This one could be 3 or 6 also because we're not sure. Okay. If this is 4, this has to be 8, which makes this a 1. That does work. If this is 2, this has to be 1, which makes that 8. But on a German whisper line, you always alternate between low digits, which are the digits 1 through 4, with high digits, which are the digits 6 through 9, right? Because 9 can only be next to a digit that's 5 away from it, and that would be 5 away or more. So that would be 9 minus 5 is 4 or less, right? So 9 can only be next to 1 through 4. 1 can only be next to 6 through 9. And if you go up or down, it's like, so if say you go down to 6, 6 can only be next to 1, period. So therefore, this has to be low, which makes this a high, which makes this a low, which makes this a high, and this a low. So this 8 can never be low, so this must be 1, which means this is 8, this is 4, which means this is 5 away from 4. The only digit that fits there is 9. 1 has to be in a 2 to 1 relationship with 2, so that makes this 4. So we know now this has to be 2 and 8, because 4 is only in a 2 to 1 relationship with 2 and 8. This is now 1, 2, and 4. This can't be 1, and this can't be 1. This cannot be 2 or 4. It could be, this can't be 4 or 8. This can't be 8. So this is a low, which means it alternates with highs, and then it must be next to another low. So if this is either 1, 2, and 4, or it's 2, 4, and 8. So this is 4, 8. It cannot be a 1 here then. We know the 2 is one of these two. This cannot be 6 or 8, so this is 7 or 9. This has to be 1 or 2 because it cannot be next to, it cannot be 3 because of the 3, 6 pair in box 2. It cannot be 4. We have a... What is in the rest of column 6? It must be 5, 7, or 9. So this is 5, 7, or 9, this is 5, 7, or 9, this is 5, 7, or 9, and this is 5, 7, or 9. This cannot be 2 or 4, because we know the 2 or 4 has to specifically be in one of these 3 cells. It could be 1 or 3, so this could be 6, 7, or 8. One of these cannot be, one of these has to be 1 or 2, because only that could be 1 or 2. This cannot be. And because of that, neither of these can be 1 or 2. These 2 digits means this can't be 1 or 2. Therefore, this must be the other 1 or 2 in box 2, because that's the only place for it. Therefore, this is 5, 7, or 9, because that's all that's left, which means this is 5, 7, or 9. Let's see. 4 is on a Ren band. It cannot have a 2, so it must have at least a 5. Right? Because you can have 3, 4, 5, 4, 5, 6, and that's it. So it's 3, 4, 5, or 4, 5, 6. So this is 3 or 6, and this is 3 or 6. This has to be 6, 7, or 8, and this is 1 or 3 also, which means there cannot be a 1. We have a 1, 3, 1, 3 pair in box 6, which eliminates 1 and 3 from the rest of the cells of the box. Therefore, the 4 must be one of these 2 cells, because 2 can only be with 4 in a 1 to 2 relationship. I can't speak. 1 to 2 relationship without 1, and 8 can only be in a 1 to 2 relationship with 4. So 4 is here either way. Also, we have a 3, 6, 3, 6 pair in column 5. Sorry, row 5. So therefore 3 and 6 cannot be in the rest of the row. So this is 7 or 8. So one thing we know is that this 3 and 6 is not the same as this 3 and 6, but it is the same as this 3 and 6. Therefore, this must be the orange 3 or 6. This must be the green 3 or 6. We don't know about this, though. What about 5, 7, 9s? This is 1, 5, 7, 9, and this is the same 5, 7, 9. This is a different 5, 7, 9. So this is a different 5, 7, 9. We can remove the blue and the reds because we know what those are. Those are highs and lows. And we can use another pair. This could be yellow, though. This has to be the last one, so we're going to make that blue. So yeah, this cannot be pink because of this one. It can't be blue because it's the last one. Therefore, this must be yellow, which makes this yellow. Right? So this must be the pink one, right? Because it cannot be... Right, this is a yellow one because it matches that. And it cannot be blue and it cannot be pink because this is the pink one. Therefore, this must be pink because this is not yellow or blue. Therefore, we know the pink one cannot be 5. It has to be 7 or 9. Okay. We don't know the difference between this orange and this green. Green cannot be here or here. Aha. So green can't be this way. Can't be any of these 3 digits because of this green, and it can't be these 3 digits because of that green. It can't be any of these cells. So the green has to be one of these 2. We're not sure which. So the other 3 or 6 has to be here. So this has to be the orange 3 or 6. One of these two is the orange one. Because one of them is 3 or 6. We're not sure which. This is the other 3 or 6. So this cannot be 3 or 6 or 2, 4, or 8. So this could be 1, 5, 7, or 9. This specifically can't be 9. This can't be 1. Yellow cannot be here and cannot be here. But it could be either of these two. So green has to be one of these 3, which isn't too helpful. This can't be 1 anymore. So this is 1 or 2, which means that must be in a 1 to 2 relationship with 2 to 4. So this can't be 8. This can't be 8. This is either 1 or 8, which would be with 2 or 4, or this is 3 and 6. Either way, I think this has to be 2, right? If this is 1, this is 2. If this is 2, obviously it's 2. So therefore, the 2 has to be one of these 2 cells, which means this cannot be 2, which means this can't be 1. So it's either 8 and 4, or it's 3, 6. I'm not sure which. Ah, well, never mind. I was thinking if it's 3, 6, or if it's 8, 4, obviously this can't be 8, so this must be 1. But if this is 3, this could be 6 and 3 here. Right. All 1 to 2 ratios are given, though. So this cannot be 3. If this were 3, this would have to be 6, and that would have to be a 1 to 2 ratio. Therefore, this cannot be 3. This is 1, which makes this 3, which means this has to be 8 to be next to it on a German whisper line. Where is the 1 in box 5? It cannot be here because of this one, and it can't be here because of the 1, 2, 1, 2 pair in column 4. And it can't be any of these because of what we've deduced, therefore it must be here. So this is a 1, which makes that a 2, which makes that a 4. This cannot be 1 anymore, this must be 2, which makes this 4, which makes that 4. We don't know if that's 2 or 8. This can't be 4 anymore, so it cannot be 4 and 8, which means this is a 3, 6 pair. This can't be 1 or 2. It could be 3, 5, 6, 7, 9, and this is 3, 5, 6, 7, 9, but it can't be 3 or 9. It's 5, 6, 7. We know 3 has to be one of these two because the 3 is eliminated from that column and that column in box 3. So 3 has to be one of these two cells, which means this can't be 3. So this is a 6. This is a 3. The rest of column 7 has to be 5, 6, 7, and 8, but 6 cannot be here because of this 6. Therefore, this must be a 6. Because this can't be 6 because of the 3, 6, 3, 6 pair here. So this is a 6. This is 5, 7, or 8. So we know the 5 has to be here. This is 3, 5, 6, 7. And these are 3, 5, 6, 7, but this can't be 3. We have a 3, 5, 6, 7 quad in row 1, which means that the rest of the row cannot contain 3, 5, 6, or 7. So this can't be 5 or 7, which forces this to be 1, which makes that a 2, which makes this an 8, which makes this a 2, which makes this 1. This is 3, 5, 6, 7, 8, 9. This is in a 1 to 2 ratio, and if it were 3, 6, The problem is that then 6 cells would require the digits 3, 5, 6, 7, and 9, which is not possible. So this cannot be 3 and 6. It has to be either 1, 2, so it could be 1, 2, 2, 4, or 4, 8. Okay. What else do we have? This is either 8 or it's 5, 7, 9. This is either 8 or 5, 7, 9. We're not sure which. Yellow's here, so therefore this is yellow. Oh, this is 4. And it has to be with then 5 and 6 or 5 and 3. It cannot be 7. So this is 5. So all the yellows are 5, which means this can't be 5. That means this is also yellow. One of these two is yellow, but we're not sure which. So it's yellow and orange. Yellow cannot be here, and it cannot be here, so this must be the yellow and 5. This can't be 5. This can't be 5, therefore this is the 5 here, and these can't be 5. This is not yellow, which means that's orange, which means this can't be orange. Therefore, this must be the orange. This is not 3 or 6, this is 5. This is a 7, 9, 7, 9 pair in column or row 3, so the rest of the row cannot contain 7 or 9. This is not 7, therefore this is 3 and 6. This is 3 and 6, which means this cannot be the green, because the green has to be this one, which means this can't be 3 or 6. We have a 7, 9, 7, 9 pair in row 2, so therefore 7 and 9 cannot be in the rest of the row. Therefore, this is a 6, and it's also green. So therefore, this is 6, this is 6. The oranges are the 3 then. This can't be 3 or 6, this must be 7, which means this can't be 7. This can't be 5. So this is 8 or 9. This can't be 5. We have here is just 7, 8, and 9. This has to be 2, 7, 8, or 9, but can't be 8. Okay, this can't be 4 or 8 anymore. So if it's 1, this has to be with 2. If it's 2, it has to be with 4. So this is also 2, 4, 8, or 9. And this has to be 1, 2, 7, or 9, but 2 cannot be here. This can't be 5 anymore. Therefore, where's the 5 in box 9? It has to be here. So this is 5. We don't need the yellow anymore. We actually don't need the orange or the green, because now it's just trying to Sudoku. These two are the same, but we don't know what they are. So we know the 2 does have to be in one of these cells, right? It's either 1, 2, or it's 2, 4. So this cannot be 2. This cannot be 2. Okay. 5, where's the 5? In box 7. It has to be here. So this is a 5. We have a 7, 9, 7, 9 pair in column 3. So the rest of the row cannot contain 7 or 9 either. Therefore, this is 1, 2, 4, or 8, but this can't be 4, which makes this 1, 2, or 8, but this can't be 2. Therefore, this can't be 2. Therefore, this is 1, 8. This is 1, 2, 4, or 8. And the thing is, if this were 2... still could be a whole bunch of stuff. This has to be 1, 8, 7, and 9. So this can't be 1. And this is 1, 7, 8, or 9. And this can't be 1. And this can't be 8. Okay. This is 1, 2, 7, 8, and 9. But this can't be 2 because of this palindrome. And this can't be 2 because of that 2. Where is the 2 in row 5? It must be here, which means this can't be 2. Therefore, where is the 2 in column 9? It must be here, which makes this a 4. So this can't be 4. One of these two is a 7, because this cannot be 7. None of the rest of the cells could be 7. So one of these two cells specifically must be 7, which means 7 cannot be in the rest of box 4. So this can't be 7. This can't be 8 because of that 8. Can't be 2. So this is 1 or 9. This can be 2, 3, 4, 7, 8, and 9. But no 7 specifically, because we know one of those is a 7. This can't be 2, 4, 8, so this is 3 or 9. This could be any of them, though. Okay. Where is the 6? The 6 has to be one of these two cells. If the 3 were in one of these two cells, it would form a 3-6 pair, which would necessitate a black Kropke dot between them. But there is none there. Therefore, the 3 cannot be one of these two cells. It can't be this one because of here. And it can't be this one. Where is it in row 2? It has to be here. So this is a 3, which means this can't be a 6, because if that were a 6, there would be a black dot between those two cells. Therefore, this is 6, which makes this 3, which makes that 6. This can't be 3 anymore. Where is the 3 here? It has to be here specifically. Because again, it would have to have a black Kropke dot next to it if it were any of these spaces. And it can't be any of these because of the 3s that are previously there. This can't be 4. So this is 1 or 8. We have a 1, 8, 1, 8 pair in row 7. So 1 and 8 cannot be in the rest of the row. This must be a 7, 9, and it's specifically the blue 7, 9. Therefore, this can't be blue 7, 9. It can't be pink 7, 9. Therefore, it must be a 1, because it can't be either 7 or 9. And both of them are the pink or the blue. Therefore, this is 1, this is 8. This can no longer be 8, so this is 1. 1's in a 1 to 2 relationship with 2. This can't be 8 anymore. This can't be 8. This is 7, which makes that 8, which makes that 9, which makes that 8. This can't be 2 or 7, so this is 9. This can't be 9. Therefore, it's a 7, 8, 7, 8 pair. What does that leave in row 6? It must be a 4 here. This can't be 8. This is now the blue 8. This is the purple 7. Or purple 7, 9. Sorry. This is the blue 7, 9. This is the purple 7, 9. This is the blue 7, 9. Where's the purple 7, 9? It has to be here. So this can't be 1. Therefore, we have a 7, 9, 7, 9 pair in box 7. So the rest of the box cannot be 7 or 9. Therefore, this must be an 8. This can't be 1, 2, or 8, so this must be 4. This has to be a 2 then. This can't be 8 or 9. This can't be 9. This can't be 9. This can't be 8. So this is the blue 8, 7 or 9, sorry. We have a blue 7, 9 and a purple 7 or 9 here. Therefore, the rest of the box cannot contain a 7 or 9. That means this is 1, which makes that an 8. Which means this can't be 8, so this is 7, this is 8, this can't be 7 or 8, this must be 9. Which means this can't be 1, this is 7, which makes that 1. The blue cannot be 9, so it must be 7. And the pink cannot be 7, so it must be 9. And that's the solution. The puzzle is solvable without remembering the negative constraint on the black dots, but much easier to solve if you did remember. Okay. It's solvable. Interesting. It's solvable without the negative constraint. I guess I could sort of see it. It does make things a lot easier, though. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.